Fireworks. How do they draw flowers, hearts, and shapes in the sky? We see fireworks everywhere, in holidays, celebrations, football matches, and even weddings. But have you ever stopped and asked yourself, how do those fireworks that light up the sky actually work? Like, how do we suddenly see a flower, a heart, or a full drawing floating above us? How does a whole shape come out of a tiny firework shell? And how can 1 second, or even a fraction of a second, make a huge difference in the engineering of fireworks? But before we start, if you're new here, don't forget to subscribe and turn on the bell so you don't miss our videos. 1. The accidental discovery that started everything. Back in the 7th century, people were obsessed with something called the elixir of immortality. They believed there was a magical drink that could make you live forever, heal diseases, and keep you young and strong. This legend existed in many civilizations, but China was by far the most obsessed with it. Some emperors even drank mixtures containing mercury, hoping it would extend their lives. And they actually had a whole profession for this. Chemists, whose only job was to invent and test immortality recipes. Until one day, while trying a new mixture, they combined potassium nitrate, sulfur, and charcoal. And by accident, when it got near fire, boom! A sudden explosion they couldn't explain. That moment was basically the first known experiment of gunpowder in history. They called that mixture something like fire medicine. At first, they didn't use it to shoot into the sky. They stuffed it inside bamboo sticks and tossed them into fire just to make loud pops. Why? Because they believed evil spirits feared loud noises and the color red. But over time, they started thinking, what if we make this explosion fly into the air instead of exploding on the ground? And that's when the earliest fireworks started appearing, like flaming arrows shooting upward. China kept developing the idea until fireworks became full royal shows for celebrations and major festivals. 2. How gunpowder traveled from China to the world. With trade routes like the Silk Road, the secret didn't stay in China. It spread everywhere and reached the Arab and Muslim world. And here's the important part. Arabs and Muslims weren't just messengers who delivered the idea, they improved it. In the 13th century, a famous Syrian scientist and engineer appeared, Hassan al-Rama, also known as Najm al-Din Hassan al-Ahdab al-Rama. He wrote books about military technology and weapons, and he documented gunpowder recipes in detail. He even gave potassium nitrate a nickname, Chinese snow, because of its bright white color, and he called fireworks something like Chinese flowers. Al-Rama understood explosive chemistry so well that he described early rocket propulsion ideas, including a torpedo-like weapon moving on water using rocket thrust. He also wrote about purifying gunpowder and defined what became the classic recipe: 75% potassium nitrate, 15% charcoal, 10% sulfur, and yes, this is almost the same ratio still used worldwide today. 3. How fireworks got their colors. Later, gunpowder reached Europe, and the people who became most famous for turning fireworks into an art form were the Italians. In the 18th century, they transformed fireworks from just loud explosions into a real visual show. They discovered something huge. If you add specific metal salts, you can change the color of the flame. Because when these metal salts heat up intensely, their electrons get excited, and when they return to normal, they release energy as colored light. For example, red comes from strontium salts, green comes from barium salts, strong yellow comes from sodium. Bright white often comes from magnesium or aluminum. But the hardest color of all? Blue. Because blue usually needs copper compounds. And copper burns correctly only within a very precise temperature range. Too hot? The color turns pale or whitish. Too cool? The blue becomes weak and dull. That's why in most fireworks shows, you'll notice blue is either rare or not very bright. So if you ever see a deep, clean, vivid blue in a fireworks show, that's usually a sign of high-quality materials and a very skilled manufacturer. 4. The engineering. What's inside a fireworks shell? Now let's get into the actual fireworks structure. The shell that launches and explodes in the sky is usually made of two main parts. Part 1, the main shell, the ball. This is the round shell packed with stars, small pellets that contain the color-producing chemicals. These stars are arranged in a specific pattern and they're surrounded by gunpowder. This is where all the real art happens. Part 2, the lift charge. Under the shell, there's a small bag of black powder called the lift charge. Its only job is to launch the shell high into the sky. So what happens? When the fuse is lit, the lift charge burns fast and produces a huge amount of hot gas. The launch tube is closed from the sides and bottom, so the gas has only one way to escape, by pushing the shell upward like a cannon shot, and the shell can shoot out at extreme speeds. 5. The time fuse. The maestro of the show. Inside the shell, there's something called a time fuse. This fuse is designed to burn at a known steady rate, meaning the engineer knows, for example, 1 centimeter of this fuse burns in 2 seconds. And this matters a lot, because we don't want the shell to explode too close to the ground, dangerous, or too late when it's already falling, ruins the shape. So the time fuse is basically the conductor of the entire show. While the shell is rising quietly, the fuse is burning inside, and the moment it reaches the end, it ignites the bursting charge at the center, boom, and the stars shoot outward and light up, creating the firework. 6. The big question: how do they make shapes like hearts? Now the real magic question: how does a firework explode into a heart, or a smiley face, or a perfect shape? The truth is, it's not magic. It's simple geometry. Inside the shell, the colored stars are arranged in the exact shape you want to appear. So, if you want a heart, they arrange the pellets in a heart pattern inside an inner cardboard frame. Then, when the bursting charge explodes at the center, it pushes the pellets outward evenly in all directions. The pattern expands like a zoom effect. So the heart becomes huge in the sky, exactly like planned. 7. From brave people to computers, and a famous 2012 mistake. For many years, large fireworks shows were extremely risky. There were people whose job was to light fuses manually, then run away as fast as possible. But today, big fireworks shows are controlled by computer systems. Each launcher is connected to electronic firing panels, and the entire show is programmed down to the second, sometimes even fractions of a second. The computer sends an electrical signal that ignites each fuse precisely. And that allows designers to launch thousands of shells in a perfectly timed sequence. Some advanced systems even use tracking tools to help ensure fireworks burst at the correct height. But mistakes can happen. In 2012, in San Diego, there was a massive fireworks show planned to last 17 minutes using about 7,000 shells. But because of a programming mistake, the duration was entered in seconds while the computer expected milliseconds. So all 7,000 shells fired almost instantly. The entire show ended in about 17 seconds. Instead of a long performance, it looked like a single giant fireball in the sky. 8. The dark side: cost, pollution, and the future. Fireworks are beautiful. They make people happy. But they also have a darker side. First, they're expensive, especially huge shows. Literally millions of dollars can burn away in the air. Second, they can be expensive for the environment too. The heavy metals used for colors fall back to the ground, and water as toxic particles. And studies have shown air pollution levels can spike after major celebrations. That's why there's a growing global trend toward cleaner fireworks that reduce smoke using different chemical formulations to reduce harmful residue. And the newest trend of all? Replacing fireworks entirely with drone light shows. Drones can create moving shapes, animated visuals, with less smoke and often a lower environmental impact. And the drones don't get thrown away after the show. They can be reused again and again. And that's it. If you made it to the end, you're legends. Hit like before you leave, so we know how many people stayed till the end. And if there's any question that hits you right before you sleep and you can't find an answer, write it in the comments and we'll cover it in the next video.